So the conflation and linking was advanced in Gazetteer Services, and I have touched a little bit about that, but I will provide more information in these next slides. So if you're not aware what a gazetteer is just a geographical dictionary. It happens that the items in that dictionary can be represented as points, for example, in the WFS, Web Feature Service, and that we call a WFSG. There are a lot of gazetteers around. One is, for example, the USGS, Geographic Names Information System, or GNIS. This is the architecture of what happened in the gazetteer work. You see on the top the client, you see that we have a global gazetteer from Envicia. On the left side, we have something called an RDF triple store that has all the semantics about how to get information from geonames, DBpedia, and OpenStreetMap OSM, and also has some of the mappings that will allow to get the relations with features in the gazetteers with these sources. And you will see also on the bottom and right the three gazetteers that we use, one from NGA, the other one from USGS, and the third one on the right side was a local gazetteer from New Brunswick. So let's concentrate on the first component, the RDF triple store. So we have, for example, here showing St. John's in one of the gazetteers, and we want to see if we can get more information about that place via the Untitled server that has information with this crowdsourced data. So here you will see that there is a link to geonames, and we can also provide, because we have all these links to geonames, Wikipedia, etc., we can bring information from Wikipedia about St. John, and the same we can do for DBpedia. And let's say, as well, we had before that, we have the same problem that we have for an area of interest. We have different sources of data that can overlap, and we want to know if there is a relation between those features. So here it's a case that we have two gazetteers, and we have these different points. They do not overlap. One has more points, and we want to know if they are, if some of those 2 points are the same, just that they happen to be represented in a different location. These some of that happen because sometimes we represent areas as points. So if we want to represent St. John is really a polygon, but sometimes it's just represented as a point. So similar as we did before, we use conflation, and in this case we're going to use again the 52 north conflation that is going to conflate between these two gazetteers. So we invoke the conflation between these two gazetteers using WorldView client, and we get some results. In this case, the result was represented with a line that presented that 2 of these points were related, and you can see more information about this relation in the left side. For example, you can see, so we're able to provide some score about that relation, and in this case it score 100%. So we were looking at the distance that were apart, the attributes, the name of the feature, all that information was looked and able to create a proper score. And OpenStreetMap, if we wanted also to be able to link those points in gazetteers to OpenStreetMap objects. And if you look, for example, St. John in OpenStreetMap, you get a geometry. So in this case, we were also able to link the geometry from OpenStreetMap to the point in a gazetteer. Now let me change a little bit of topics. So I'm going to talk about how we did some sophisticated searches using global gazetteers. So you will see here that the client WorldView is interacting with the global gazetteer that is able then to get the request and do multiple requests to other gazetteers. This is called cascading request. But we did a little bit more than just cascading. So let's assume that a user wants to search for any features that are summits, and the user gets some results. This is, again, remember, is interacting with the global gazetteer. So you will get these points that are summits. If maybe you will not realize what's happening sort of behind the scenes. And in the left side, you will see that there are features returned that are not only summit, but also features that have there are mountains, there are hills, there are ridges, and so forth, because we were able to do this semantic mapping with those concepts. So you type summit, and then you get all the other features that are somehow related, semantically related to summit. And we perform two interesting searches that are mostly not supported in a normal WFS, but very interesting in Gazetteer Services. One is a Radial Search that says, well, I'm here in this point, I want to know everything that's around me, for example, 5 miles. And also another important search was, for example, one that says find airports near Summit. So I want to get the airports, and I want to get them ranked based on distance. So that was also implemented in the client and in the server side. So here are the results. You see yellow are the airports that are nearby one of the triangles that represent the summit. And you will see also the distance. So it found the 5 nearest airports. So as a conclusion for the WFSQ, we're able to show that we're able to link to other sources, crowdsourced data, like OpenStreetMap, DBpedia, GeoNames, show that we're able to conflate and show the relation and provide a score if we have data from different sources for a region that do not totally overlap. We're able to do some semantic matching that allow to do better queries, in particular when we have global gazetteer searches. We're able to do sophisticated spatial constraints like nearby and radius, and we're able to cascade these rich semantic searches via virtual global gazetteers.